Here we are, Intro to Trigonometry. This is the first video in the series of videos of instruction for this course. The first semester we're going to be going over trigonometry, and then in the second semester we're going to be reviewing some of the algebra topics so that you'll be fully prepared and have all of your mathematics shored up and ready to go. I hope you enjoyed the cartoon. Here are the objectives that you need to write down in your composition notebook. Trigonometry is the study of the measurement of angles. It's from the Greek triangle, trigonon, and measure, metron, so trigonometry. So because angles can be put together to form triangles, trigonometry is also a very good study in triangles of every kind. And we use trigonometry in so many applications in life, measuring how tall things are, measuring the distance between stars, things in our solar system, and many other applications. But be sure you get the definition for trigonometry in your composition notebook. Here are some more applications using trigonometry. Old style navigation at sea used this first device called a sextant, and this sextant uses celestial navigation. And they used that for a very long time before GPS. Light wave refractions depend on trigonometry. You can see this is 3D trigonometry. And then this is sound waves. Sound waves are all sinusoidal, so doing periods and amplitudes using sound waves. Orbits of atomic particles look like polar coordinates. They look like polar equations and polar devices. And pendulums also, you can kind of see the triangles here, depend on trigonometry. Notice the notation, right? Math is about notation, and so we're going to learn about these different types of notation. Here's some other planetary orbits. What we also know is that most orbits are ellipsoid shape, elliptical shaped. But you can kind of see here how you end up with triangular and different types of orbits. All you have to do is look around, right? Look around you. You can see here that there's all kinds of triangles used in the supports. Many of you in pre-engineering have used trusses and used trigonometry then to divide and find the loads that can be borne by different style triangles. Global positioning systems also use trig. It's usually some kind of triangulation method when you are sending signals up and bouncing them off of a satellite to determine exactly where the position of the object you're looking for is. It also determines the latitude and the longitude. Music, digital recorded music uses a type of cyclical waveform. This is MP3 format. We have MP4 now. But it also involves trigonometry. Trigonometry is an ancient study, as is most of mathematics. Ever since people began counting on fingers and toes, they've developed better ways and better tools to describe the world around them. As science has developed, the mathematics has kept up, and we have been using mathematics to explain phenomena in our world ever since. You can see that the ancient Greeks had a very sophisticated, believe it or not, astronomy, understanding of astronomy. And by the middle of the 1st century BC, we had several things. You can see the tablets here, stone tablets, and some of the other artifacts that survive from that time. So trig was developed all those years ago. So angles can be measured in two different ways, and traditionally in all the other times that we have studied angles, we have used degrees. And most of us, that's based, of course, on a circle. With a circle, every circle, no matter how big or small, no matter if its radius is itty-bitty or really big, every angle, all of the angles in the circle add up to 360 degrees. That's just always true. If I cut it in half, then I have a supplementary 180 degrees. If I cut it in half again, I have 90 degrees. Right? And so that seems pretty intuitive to us because that's what we've always used. But in this class, in trigonometry, we are going to be making the transition to another measure of an angle called a radian. So why radians? Well, here are some reasons. I've written them out here. In science and engineering, radians are more convenient because they are smaller. Okay? So, for instance, I told you every circle has 360 degrees. Every circle also has a circumference of 2 pi times the radius, because pi is defined to be the circumference of any circle divided by its diameter. Okay? So, and you can derive these two formulas from each other. Well, okay, say your radius is 1. Say you have a radius of 1. Then that means that the circumference of a circle with a radius of 1 is going to be 2 pi. Right? So if we start here, half of 2 pi is just pi. Right? And half of pi is just pi over 2. So pi, half a pi, and then counting. Right? So 0, pi over 2, pi, 3 pi over 2, 2 pi. And so what we can do then is we can talk about parts of a circle in radians, and then talk about things like how fast this angle is moving, angular velocity, or how fast a particle traveling in a circular orbit is also traveling a rate of change. And so radians are going to be very important. Another thing is your calculator. The calculator is going to be, the default for a calculator is radians. And you probably saw that because it just seemed like every single time you wanted to do something in geometry class with an angle that was in degrees, you were always having to change and change and change. And that's still important. It's the mode on there. But we are going to make the transition to radians. So we've kind of talked about circles, right? We talked about a circle with a radius of 1. So here's the radius on this circle, and it is 1. And notice that I did not put 1 inch, 1 centimeter, 1 whatever unit. I just said 1 unit. Okay? This one also has a radius of 1 unit, generic unit. These two circles are not congruent. They're not the same size at all. Okay? None of them are, none of the three. But they all have a radius of 1 unit. Okay? And if they all have a radius of 1 unit, then their circumference is 2 pi. Now, that's kind of an interesting thought. But this idea of a unit circle means that all of these radii, even though they're not the same length, they're all 1 unit. But if I say 1 inch, 1 millimeter, 1, I'll make this centimeter, that seems like that's centimeter, and 1 millimeter, then can I say they're all unit circles? Interesting question. Okay, so we're going to ponder these kinds of questions later on, and we are going to define exactly what a unit circle is. And it's going to be something that we are going to be living with for a while until we learn it. And I don't mean memorize it, I mean learn it so that it becomes second nature. But I wanted to introduce it in this one, on the introduction to trigonometry, because we've already looked at right triangles, and we're going to marry right triangles with a circle to get a unit circle. So stay tuned, and I hope you took good notes. Just a few notes on some of the applications that we use for trigonometry, and also what trigonometry, where they got that name. And there's not a whole lot of notes on this particular video, so I will check them in class and we'll talk about them. All right, so see you then.